So we're talking about vectors and the implementation and its implications in the e-commerce. So let's get started. The ticker works. So a little bit about me. I've been working in domain of search since 2008. Yeah, I'm pretty old. And I contribute on several projects in search and related domains. Yes, I have been a developer. I have got 2 masters, and personally I'm married and I have 2 boys. And I love exploring new places, and I love cooking food from different cuisines. Might as well cook Polish food. So that's about my company, OpenSource Connections. I think you guys pretty much know about us by now. So one thing that was not there on the slides is that I come from Berlin. That's where I live since last 5 years. And we are very blessed that we have a lot of technical meetups in Berlin. And since last few months, or I would say more than half a year, all these meetups that I go to, people are discussing so much about vectors, like, oh my God, vectors is like, it's going to bring revolution. And it seems like they're already very impressed with what vectors could add to any search engine and the capabilities that it could bring to e-commerce especially. But at the same time, they're also struggling to understand what vectors really are. So maybe at this point in time, can I have show of hands, like how many people are working on vectors? Wow, that's impressive. So for the ones, this topic is kind of new, maybe we can understand what the heck this vector search really is. So it's not a rocket science and it's not a new concept, so to say. In fact, our traditional keyword-based search engines also work on vector search. Just that the inverted index that we usually use with our keyword-based search engines use the sparse vector representation of the documents, which means that the documents are represented in zeros and ones. For the keywords which appear in a document, obviously it's a non-zero number, and for the keywords that are not present in the document are usually represented by a 0 for the easier calculation. But we are going to be talking about dense vectors today, and it works by converting your text into a vector or the embedding format, which is usually the float number, and you can do that by using any desired transformer. So I would be discussing about a small POC in later part of my slides, and we have experimented with the mini element clip in our case. So the idea then is that we create the index and we search through these vector encodings that we have generated of our documents. The idea of the encoding, why is it so special, is that we try to capture the semantic meaning of our documents. So it's not only relying on what keyword is, how keyword is describing a document, but also trying to take a step further and understanding what it really means in the semantic terminology. So to say, if the document isn't really describing some features of the product or the document in certain keywords, it would still understand because the focus is the semantic meaning. I would also like to draw attention to this graph that we have here. So if you look here, we have tried to kind of give a picture to how the vector space model would look like. So you see here that there are small clusters here. So we have one cluster of the laptops, one cluster for the mobile phones, and the cluster which represents tablets. On the other side, we have baby products, and backpacks and handbags are kind of on the other side as well. So the idea is that because we are caring for the semantic meaning, that's why the baby products are going to be on one part, so to say, because they imply the similar kind of products. Similarly, tablets being closer to laptops and mobile phones, so it is going to be closer to that cluster. So for example, if somebody's looking for a baby backpack, it's something related to babies, but it is also a backpack. So which is why it's going to be somewhere in between. Similarly, the gaming console is something which is meant for playing, but it falls into the category of electronics, which is why it would be somewhere between these clusters. So the idea here is that the semantic meaning is kind of captured, and in the similar space, we encode our queries. So, which is why it's kind of rather very performant, and you get pretty accurate results as well. So also the traditional search revolves around the keywords, while the vector search really takes a step forward and finds the documents which are most similar to your query vectors in terms of semantic meaning. So you may be wondering that how can we leverage this capability that vectors could bring in the e-commerce search? So to say, it's very active area of interest, and there are some pros and cons in the e-commerce search. For example, we are blessed to have access to images, but some content could be pretty much repeated throughout the fields, such as it's kind of different than the other domains. I think Renee pretty much covered that how different e-commerce searches are different, and like, for example, music search is different from e-commerce. So similarly, we have found that the vector search is kind of very, having a lot of implementations and fixing the recall issues. So for example, a keyword-based search engine does have a hard time giving good results for long tail queries. This is where vectors are really helpful, because the essence is on understanding the semantic meaning. Also, there could be zero hits unless you're handling them by synonyms or additional handling. You might as well run into a zero hit situation, because the keywords probably are not used same as the one used in query to describe the product. So that's where the vectors could also help, because there are several meanings with which one product could be known for. Like laptop could be known as also a notebook. So backpack could be something like a rucksack as well. Also, one of this meetup that I recently went to, I think 2 or 3 weeks ago, I was very surprised that a company, a pretty big e-commerce giant company, which is running their shop in multiple countries, actually converted their double-digit zero hits into almost less than, like, kind of, I think, less than 5% by implementing the multilingual BERT model. And that is how they transformed all their different language searches, which were earlier running into a zero hit situation, and they were now giving results, and relevant ones, at least the closest ones. That's what they showcased in the meetup. Also, it exposes a lot of potential in terms of implementing better personalization, because you could map and detect similar users and understand that 2 users could have different kind of or similar kind of interests. So in terms of marketing and promotion, it's also very helpful. I think recommendation and suggestion is like a very classic case of using vectors, and I think that's where it's kind of really shining. So the benefits, so to say, is to leverage the power of deep learning and machine learning models into your search, which is obviously not a new thing, but it just takes you a step ahead. Also, one thing that I probably did not explain in a probably better way is that there are multimodality, which means that different kind of media contents like images, audios, and videos, which can be used to describe products, are mapped into the single vector space model. And so as your query also comes in, like your text query comes in, and that is also mapped into the similar vector space. So you could leverage other means to get more nice results, deliver better results, and improve the user experience there. You could also boost the precision. Again, I know I'm using semantic a lot, but that's what vectors are all about. So you can boost the precision by leveraging the semantic meaning of the query, and I would also take you through some examples where you could understand in a better way what I really mean here. So I think if you have not been working on vectors by now, you must be really excited that how do I get started? So I asked my new best friend, ChatGPT. I think he's in pretty much every discussion these days. So I asked ChatGPT, like, vector search is super great. So how do I implement it in my e-commerce search engine? And it came up with these 4 steps, which pretty much covers everything. So the first it says is that you need to gather the data. So of course, you need to gather the data. If you're already running an e-commerce shop, you would already have the data. The second would be that you need to vectorize your data so that you could use this vector space to map your documents as well as your queries so that you can calculate the nearest neighbor, or at least calculate the similarity and the distance between these documents and the query vectors. You would have to make a change to your search algo depending on how courageous you are to try vectors. You might as well completely change your search algo to use only vectors, or you might as well use it in the combination with the BM25-based search algos. And test and optimize. Sounds simple. It says good luck as well. But the devil is in details. So we understand that it could be very complicated process to gather all the tools and bring this all together to improve your e-commerce search engine, which is why we came up with Chorus. So again, a show of hands, how many people are aware of what Chorus is? Okay, then I think it would be interesting to go through it. And I might also have kind of a small guess the logo challenge. Can anyone guess what this logo is? Sorry? Wow, you won yourself a chocolate. Okay, whichever the sound came from this side. Okay, so yes, it's a Dockerized image, which consists of course, Docker. The search engine is based on Solr and Elastic. I'm not giving any more chocolates because rest of it is written on the slide. The UI is based on Blacklight. And we have the query rewriting part taken care of by Quirky and Smoey. We have Cupid. I think Renee already presented Cupid in the previous session. So that is used for improving your relevance and ranking, ratings as well. You can collect your judgment list with it as well. And last but not least is the rated ranking evaluator. So all of this in combination forms the Chorus, provides you with all these toolkits, and you can get started with your e-commerce search engine, or you can improve your existing e-commerce search engine with this. So once you have access to the slides, I guess you can go check out this GitHub link. So what's new with it? So what we did is that we added vectors to this Chorus. So along with all the components that we just showcased on the previous slide, we added vectors by adding an additional embedding service. Obviously, this was kind of essential because the part is that we need to interact with encodings, and this job has to be done by someone, of course. So I think I would rather focus on this side of the slide here. So the data encoding process is more like an offline process. We have scripts available in the code base already. So what we did is that along with the existing Solr schema for the e-commerce search, we added two new fields, one to store the text vector and another one to store the image vector. Remember, we are dealing with e-commerce, so we have access to the images. So we have used two different models here for text and the images. There were certain limitations with the clip model dealing with the text part because we can only encode 77 tokens with it. So obviously it was not really fitting that well in the use case. So which is why we used MiniLM for the text encodings and clip for the image encodings. Obviously you are free to try the other ones as well. So the idea is that this encoding process will augment these two new fields into your data set. And that is what we then use into our Solr. So the data set is then added into our search engine. So we use Solr here. And that contains, along with the data set, of course, we have quirky rewriter config. And along with that, we also have the query model param set. So what happens now is that when the user sends in the query, it's a text query, of course, we present to the user 4 different models with which they can interact with vectors. So 4 different models are such as you can use your text query to completely match on the text vector field, or your text query to match completely on the vector image vector field. Or you could also use both of these new fields, the text vector field and the image vector field, as the boost query. So when the user selects whatever he wants to do, whichever query model he wants to interact with, he sends in the text query. For the given query model, we pick a designated param set. This is already defined in the configuration and very easily configurable once you check out the code. So the param set basically describes that which quirky rewriter config it needs to pick. So it goes to quirky, which can use this param set config. It also defines that the query is going to be either transformed into vector completely, so it uses it as a main query, or does it wants to use the vector query as a boost query. So based on that model, it sends the request to our encoding service, the new component, and that exposes two APIs right now. One that generates the encoding in the mini-LM model, the respective to mini-LM model, and the other one that generates the encoding based on the clip model. It is essential because mini-LM gives you the encoding, which would be of 384 dimensions, and the clip model would give you embeddings, which are going to be of 768 dimensions. So that is one thing that we need to be watchful about here. So based on the rules, the quirky rewriter config, and the encoding service that generated the encoding, we get back the encoding, and then quirky rewrites the query again, using either transforming the query as a main query, or using the encoding as a boost query, and sends to Solar. And the respective results are then returned to the UI. We would see this in action, so don't be overwhelmed if you do not understand this right now. We are using the IceCat dataset in Chorus, and that is the dataset that we have used to also vectorize and experiment with. Using a different dataset is fairly easy as well. So at this point in time, I would like to give you a small demo of how it looks like. So that's how our Git repo looks. That's where Chorus is. And that's how our UI looks like. The query models are exposed here. If you look, there are 4 new models. So I would start with maybe the first query, notebook. And maybe we can use this one so that we can see majority of the search results. If you notice here, that's kind of one of the problems that the keyword-based search engines may have, is that it may pull up a lot of accessories related to this query keyword. So it would not really understand that I'm looking for actually notebook, but it would fetch everything that would mention notebook anywhere in their title or description. Let's try the same query with our vectors. And I think you would already see the difference. We can still see some sort of things like notebook or telephone holder, which probably do not really belong here, which does implies that the models that we have used off the shelf are probably not the best ones. They still need fine-tuning. So I think in the interest of time, I would not spend too much time on the demo, and I would show you maybe rest of the queries as the snapshots. I knew this might happen. So as we saw that there were a lot of accessories, and when we tried to use the similar query with the vectors, the text vectors, we got pretty much, at least the top results were notebooks, the real notebooks. We tried another query here, and we tried to use projector screen this time, because we were trying to kind of go bold with the number of keywords in the query. So we tried projector screen. We got 2 projector screens here, but rest of them were more like accessories or supporting components of the projector screen. However, when we used this on the text vector side, we pretty much got all the projector screens, really. If you look at this query, this has got 2 typos. The brand is called Lexmark, and the cartridge, the word is misspelled. If you see how beautifully this actually handled, and I think the default algo pretty much went bonkers. So, but we got what we wanted by using the image vectors this time. Similar was the network cable. I think you might have seen that that was the same snapshot in my diagram. So we got all sort of power supply cables as well there, but we actually got network cables when we used the query model from the vectors. These are my friends from the meetups who were very confused in the beginning of the presentation. Looks like they're happy now. But I would say, as I already said, there are still some fine-tuning capabilities required, and there are some caveats. So finding a vector model or the transformer which is suitable to cater to your business needs may be a pretty intensive job. Also, dimensions, they're not free. So imagine like you adding another field in your index which would occupy the dimensions of 768 or 384. That's actually a lot. That would require you to spend a lot on your memory footprint as well. I think needless to say, but I would still like to mention that we also tried this with OpenAI model, which actually has the dimension of 1536, and which is probably one of the reasons we avoided that at the moment, but still the model is available. The encoding service supports it. There are limitations on the length of text that can be encoded by different models. So that's like another limitation. The infrastructural changes that would be required to support vectors, because we need high-performant encoding service for implementing maybe in the index pipeline and also during the query pipeline. That would be also something one needs to keep in mind. And that's the same thing. I would like to say that fast and scalable vector search service is another thing that obviously is a matter of concern. We have planned some further improvements on this course. This is already open sourced, and there are still some improvements planned for this one. So we understand that a lot of e-commerce companies train their own models. So we are going to add support for supporting those custom trained models as well into this. The image vector search quality probably needs a little more love, a little more kind of attention here, which is what we are also looking forward to improve upon. We also want to add the fine-tuning capabilities for hybrid search. So if you see the example where we were using the vector search query as the boost query, this is the example of the hybrid search, but we want to add more fine-tuning capabilities to it. We understand that the e-commerce search is kind of tricky business because there may be some sort of like legal searches. You have to boost some brands, you have some promoted searches, so on and so forth. So this is another kind of area of improvement. How do we achieve that with vectors to kind of achieve good relevancy with manually manipulated search results? And last but not least, we want to add vector-based re-ranking model as well. So all of this is in process, sort of, so keep watching this space. Maybe we would give another presentation about where we are with that in future. At this moment, I would like to acknowledge that all the images in this presentation were created using DALL-E, and the diagram has been generated using the Draw.io. So that's about it for the presentation.
Thank you for your talk. As filtering is a very important part of e-commerce search engines, I'd like to know how do you approach it? What kind of filtering do you support? Mm-hmm. How does it impact your performance? Mm-hmm. And what the strategy you use, like post-filtering, pre-filtering, or something else?
So, okay, that's a pretty good question. And in fact, the demo, I mean, I know that I was running short on time, but if you look at my demo here, we already have implemented some of the filters. So they're already there. We have understood that this would be bare minimum, which would still be required. The idea is that we would use the post filtering on the results and then exposing these filters, which are dynamically generated. So that's what. So good to kind of check out the code as well.
Thank you.
Okay, so you mentioned that you have like two different vector spaces for like images and text, but I assume that in order to use images in text search, you first need to kind of categorize the text and actually like the image, and actually know what's on the image, right? And then you have the text from the image, and then you can kind of use the same model to vectorize that. So why did you use this like separate algorithm to vectorize?
That's a good question, and I think the idea was that we wanted to exemplify the multimodality. We actually wanted to stick to CLIP for the text embeddings as well, as I mentioned, but it had limitation on number of tokens. So the text encoding that we generated were using title and the brand field. I think people would like to add more and more text fields from their documents, but we wanted to support at least 256, so that because some of our titles were really long. So this is the reason why we switched back to another model where we could have more independence. But the idea was that we wanted to have something with which we could do the image to text search and vice versa.
Okay.
In this vector search, we encountered one issue, which is the precision recall threshold. It is, I think it's non-trivial to implement in this approach the good threshold to say that using vector search we have exactly, 50 products which match your search criteria.
Right.
And do you have any tricks or tips how to approach this issue?
I think that's something I also encountered as well. I think there are some searches here in which I got exceptionally good results, but maybe 2 of them or 3 of them were like super relevant, rest of them like partially matched. So about the threshold, I think that's a good topic for discussion maybe. I don't have any ready solutions. You have an answer to that? Okay. Okay. So yeah, but we can, that's probably a good maybe kind of bend to follow that. Thanks for bringing that up.
I think it's a very interesting topic. In general, I think that vector search is very fascinating, but it's not a silver bullet for everything. And full text searching, traditional one, will be powerful when we have, I don't know, short or very exact queries, very precise queries. Correct. I think maybe it's a matter of identifying type of the query, and then you need to decide for this query, maybe it's better to do a keyword search, traditional one, when it's very precise and exact. Product name, model name, or something.
Agreed. Yeah.
But in other cases, vector search, when we want to go beyond keyword search, can be helpful because we want to, match things which are relevant, similar, close, but maybe not exactly with these words we used. And you need to find the balance in it. And you had this in the conclusion slide that I think one of the most interesting topics is to find a hybrid way and having vector search and full text search, keyword search in one request to Solr, Elasticsearch, or whatever.
Correct. Yeah.
So that was my comment, and I also have a question. Have you been thinking about highlighting and vector search, considering that fact when we use vector search, we are interested in this similarities and words which are related but not exactly the same? What will happen with highlighting when we want to, bold some of the words in the text and explain why we match this result?
Right.
I have no idea how to do that, but I think that highlighting will have a new meaning in the vector search, but I don't know how to provide good highlighting with vector search.
Sure, I think that's a pretty good topic for the discussion, and I would also like to add one more comment, because again, I think my interest still lies in the meetup, and I think this is like another good point that a lot of companies which are experimenting with vector search, they try to implement vector search in the topics or in the queries where they find it difficult to serve any results with the traditional BM25 match. So what they do is that they put kind of like a chain that if we are running into a zero-hit situation because the query being too long, or I'm running into like zero-hit situation, this is when they trigger the vector search results so that they can at least show something to the user on the user interface. So that's probably been like pretty safe approach to kind of deal with it, like trigger it selectively on some part that is not handled well with BM25.
I think that's at least 3 topics for the barcamp. Yeah, so that's
For sure.
when to use vector search, how to deal with result counts, and how to deal with highlighting, right? So it's a highlight, so to say. All right.
I would like to still give you a chocolate. That's what I have.
We even have books, Atita. Okay, any further question to Atita? But in the interest of time, I think we should refer to barcamp. Let's give Atita another round of applause.
Thank you.